So sequence diagram, we learned about how we draw the objects and the activation rectangle. We call it as an activator, which indicates the timeline. And we learned about these message symbols, what is synchronous, what is asynchronous message. So dashed line that goes with this kind of an arrow is called it's an open stick arrowhead, which is called asynchronous. Asynchronous means the sender transfers control to the receiver and doesn't wait for the operation to complete. That means it doesn't expect anything in return. Whereas if you have a synchronous one, it is a dark solid filled arrowhead. It involves a return message from the receiver. It's expecting a, so it's like a request message, request function we see, and this is optional one, which indicates a notification or return message. So we discussed about first of all, we went through an example of cars and car keys and how we draw the interaction between that happens from a car owner to the car through a car key, right, through an interface, how they communicate with each other. So we went through those examples, and then we discussed about a soda machine, where mainly three components are involved in a soda machine, which is based on this class diagram. So a soda machine consists of a front and a register and a dispenser. So front is responsible for, like it is the front area where you put the money and maybe receive the soda. It's that area. Then you have the middle part called the register, that is responsible for doing the calculations, verifying the payment, verifying whether soda is available or not, and so on. And then you have the dispenser, which is responsible for releasing the soda cans. So we discussed different scenarios, success scenarios, and certain other alternative scenarios where if soda is available, soda is not available, if the money entered is sufficient or not. We drew different separate sequence diagrams for each scenario. I mean, we discussed about separate scenarios. So now what we were trying to, what we were left was with how do we combine all these sequence diagrams as a one thing, because we can keep on drawing sequence diagrams for each scenario, that is fine, but in some cases if it's a reasonable project, we may need to combine all. It will be easy if we can see all these cases in one view, right? So for that we call that as a generic sequence diagram. Okay, so let me quickly go through this. There are some small things that will be introduced in this, which you may need to take note of. Let me open up the slides as well. So this is what will be the summary. Let me first go through this and then come back to that. So generic sequence diagram. So far you put just one scenario into a sequence diagram. When you do this, you create an instance sequence diagram. If you include all of the use cases scenarios when you draw a sequence diagram, you create a generic sequence diagram. So now we are going to put all our scenarios into one diagram. So we need some way of indicating conditions. One condition necessitates the messages in one scenario, another condition necessitates others. So as previously we saw, Here you can see sequence diagram for the incorrect change scenario. Then you have another one, sequence diagram for the incorrect change and machine is out of change scenario. So these are different things, but when we draw it in one, you have to mention the conditions separately. So recall from the example with cars and car keys that UML provides the guard condition. You remember that we draw it in square brackets, something like this, right? So same concept you can introduce it here as well. So recall from the example with cars and car keys that UML provides the guard condition to indicate if. This is just a bracketed statement for a condition that has to be in place to follow one path rather than another. For example, to show that an object sends a message only if the selected soda is sold out, preface that message with sold out. So if you have one scenario and you know this interaction is going to do only that thing, you mention that condition in this. So when you look at the diagram, it will be easy to understand, okay, this thing will work only in this scenario, something like that. We'll look at that as we see it. The guard conditions provide essentially the same information as the return messages. For example, sold out lets you know that the selection is unavailable, just as the sold out return message does. For this reason, you can remove the return messages. Keeping them around would make the diagram cumbersome. Okay. So in our earlier example, we drew guard conditions not like this or not like this. Except what we did was we gave these Boolean conditions, no, greater than, less than, if it is equal to this one, if the button is in that car key example, you remember, if the button press is open. So we check for equality or some Boolean condition. But here same guard condition is used as a message instead of a return message, we use a guard condition. So in that case, when we use the guard condition in this way, we don't have to mention the return message. One more idea, and you'll be ready to take the plunge into generics. You want to be able to show that if you fully follow one scenario sequence of messages to its conclusion, the transaction is over, and that the remaining messages are related to other scenarios. To do this, you preface the final message in each scenario with transaction over. So this is to again add simplicity or to reduce complexity in understanding when you have multiple scenarios in one sequence diagram. Let's say you are leading the person, you are leading the user to look at all the scenarios, look at all the messages or functions that are happening in one scenario, and you want to indicate that that scenario is complete, you can use the final message or final interaction with this label, transaction over. So then the remaining things will be easy for you to understand the other scenarios. So let's see how they have put this into one view. If you look at this thing here, we have the customer introduced as the external actor or the object, the fronts register and the dispenser as usual. Now if you look at this interaction, customer is calling the fronts function accept by passing the cache and the selection option. So it is a synchronous message. Then front is in turn calling the register through the get customer input message of the register class. And here you have a guard condition. The register is checking whether cache is greater than the price that is sent here, and it will check for the change. It will check for the change, like for example, if the price of the soda is 100 and now the cash entered is 150, so now we need to give the balance 50. So that is checked here, right? Check for change, right? Then once that is checked, so it keeps on checking that, and in this scenario, this is the scenario where the change is not available, right? So then what happens is you use a guard condition with the function of the front, return the cash, because now there's no balance to give. I mean, there is no enough, the 50 rupees is not available on the register. So you have to return the total cash, 150, back to the person with the condition, no change. With that, we conclude. See here, the use of transaction over, no change, with the message, okay, use correct change. So with this message, we know this scenario is over. From this point to this point, where the no change scenario is over. Now, if you look at the next one, again, you have to understand the remaining parts, you have to start from here. Accept, so customer is sending the same scenario, getting custom input, checking cash price is greater than thing, and if it is okay, it continues here. So this is how you have to read it, from here to, from this one, third one, and then the fourth one here. So this is going to the other scenario, right? So it sends a synchronous message, and then you can see if the soda is available or not. If the soda is available or not, right? Then you can see it is sending a message, okay, in this case, the soda is not available. So we say sold out. You send a message with the guard condition, display prompt. So display prompt is again the same message, same function that is available in the front class. So you call that function, and then you say transaction is over. You call it with the return cash function. So that scenario is over. So then the third scenario, again, you have to start from here, 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 here. So now soda is available. So you update, then you send the change, so the balance, if the cash is greater than price. So if this is true, it happens. So that is another scenario. So do you understand? Then finally, you call the release soda function, and transaction is over with selection available guard condition. So is this clear for you? How you draw using the guard conditions? So this is the very simplest case of how you include all the other conditions as one. Do you understand this now? Any questions on understanding this? Okay, good. Let me go ahead. Follow the diagram from top to bottom. So it's explaining what I explained here. I'll just go through that quickly. It's a very simple concept, putting all this together. So follow the diagram from top to bottom. It starts with the customer requesting the front to accept his or her cash in selection. Next, the front asks the register to get the customer's input. If the cash is greater than the price of the soda, the register checks if its cash is sufficient. If no change is available, the register has the front return the customer's cash and uses a prompt called use correct change and the transaction over. Then you go into the register's lifeline. You are in effect looking at a different scenario, as I mentioned. So and so and so forth, it goes on. Right? That is what is explained here. Are you getting the idea that behind every use case lurks one or more sequence diagram? If so, you probably understand why a sequence diagram is a valuable thing. As you'll see in the later chapter, working with active diagrams, that is going to be the next one. UML 2.0 offers an alternative way to combine sequence diagram called interaction overview diagram. Right? So we'll be learning that in the next session. A different way of showing these sequences. Now as you can see, this is showing the dynamic behavior of a system that you are designing. How the objects are going to interact in some kind of a logical order. So other diagrams which you learned, class diagram, the other kind of diagrams and all, this was not possible. I mean, you can't see the flow. So this is what sequence diagram is very important for, to understand the flow of events happening across time. Right. See. Okay, create object is not available for you. Don't think. Okay. Well, anyway, cover this one as well and then move on to the next. Right. There's additional stuff, but anyway, I'll cover along this. It's a small thing, nothing complicated. Now, all this time we discussed about objects that are already known from the problem domain and things that we, so in this soda dispenser, we know these objects are directly involved. Customer, front, register, dispenser. Even in the car interaction scenario, car owner, car key, and the car itself. So these are all the objects that are already known before you start designing. Now, sometimes you may have a scenario or you may have a situation where when you are drawing, when you are doing this interaction, some dynamic objects might come. That means temporarily. It might be not permanently in the design, but temporarily that might be needed to, finish the interaction. So that is what we are going to discuss here. Creating an object in the sequence. As the sequence is going along, you create an object and destroy an object. So how do you show those kind of things in a sequence diagram? So a few years ago, telecommunications giant Ericsson, Sony Ericsson, that company, demonstrated technology that enables customers to use their cell phones to buy from soda machines. A commercial during a recent Super Bowl telecast portrayed this technology in action. How do you model this interaction in a sequence diagram? What would you have to add? That means they are now introducing another object, another way of interacting that same soda machine scenario, but now using a cell phone. So let's begin once again with a class diagram. So if you look at this, you are using a wireless connection here. So the existing soda machine diagram, we had only these three. Now we are introducing a cell phone object, which a cell phone has a phone number and a get in button press method. So through wireless connection, it is going to connect with the soda's front. So when it is going to do a connection with this, as a result of making this connection, it is going to create a record. So we call that transaction record, which will record the credit card number, date, what selection was made, and the price of the soda if necessary, right? So this class here is not going to be permanent, because now imagine if cell phone is not used, this transaction record is not needed with credit card number details and all, right? That detail is not going to be needed. Okay. So that's why we say this is like a, temporary object or temporary class that is created only for this special case when the cell phone is used, right? So that is what is explained here, I believe. So we use a wireless connection. The cell phone interfaces to the front. The front is smarter than before and now has the ability to process information from the customer. In this version, it requires an additional capability. The real focus here, it creates a transaction record of the interaction between the customer and the soda machine. The machine uses this record to charge the customer's credit card for the soda. So your sequence diagram has to visualize the creation of the transaction record. So here you can see the transaction record object is created because we need to capture the scenario when the user is using the cell phone. So onto the sequence diagram, we'll work with the best case scenario first. The customer keys his or her credit card information into the cell phone and sends it to the front. The front processes the information and displays an approved prompt to the customer, because now if sufficient money is there, only he can proceed, no? So the customer keys a selection into the cell phone, which sends it to the front. In this version of the soda machine, the front processes the information and communicates directly with the dispenser to check availability and to instruct the dispenser to release the soda. Now you can see in this case, when the cell phone is used, register is not needed, because now this is going to happen through a different way. So front will now interact with the dispenser directly. In the manual scenario, yes, register is needed to check the change and etc. But now since credit card is used, you enter only the correct details. I mean, that is what is expected, no? So in this version of the soda machine, front processes the information, communicates directly with the dispenser to check availability and to instruct the dispenser to release the soda. The rest of the scenario is just like the original best case scenario in the 20th century soda machine, except for the creation of the transaction record. Right? Okay. So the rest of the scenario is just like the original best case scenario in the 20th century, that means the old soda machine, except for the creation of transaction. Right. So if you look at this diagram, updated diagram, right. So what is new here is you don't have the register, and now you can see along the sequence you have the transaction record created. Okay, so easy to understand. Now this language already you know, in sequence we have learned. So customer is calling the cell phone's function get button press, cell phone is calling the front is processing the customer info function and displaying the prompt approved, and then once he receives the approved message, I think that message need to be sent here, and then customer is making the selection of the soda that is processing, is checking the available. If it is available, release. So if it is available, you now start creating a transaction record. So this is where we use that create label, right? And then from then onwards, that transaction record is going to talk with the dispenser and receive the soda, and that's all. Then that communication finishes. So this figure represents the sequence diagram, updated one. All the objects are across the top except the transaction record object. Why? Because it's not one of the objects that exists at the beginning of the sequence. So I hope you understand this point. The transaction record just came in between. It didn't happen in the beginning, because we don't see that physically. We don't see that object physically. So only the main things we see physically in the problem description, we put them at the top. All other intermediate objects, whenever necessary, come at the as the sequence goes on. That's what they say. So except the transaction record, all the objects are at the top. Why? Because it's not one of the objects that exists at the beginning of the sequence. You show its creation by positioning it in the vertical dimension according to when it's created. Another aspect of modeling object creation is the create keyword you put on the message, sent from the create object to the created object. Because the register isn't involved in the sequence, it doesn't appear in the diagram, because that is not necessary for this interaction where the cell phone is involved. So you can see here, who is the creator object of transaction record? Creator and created object. What is the creator object? What do you mean by creator object? Who is the creator object of transaction record? Creator object means the object that is creating the object. So what is the creator object here? No idea? Let me go back to that point. Cool. So when you are creating that intermediate object, now transaction record is the new object now. So what happens is we use the create keyword. You put on the message sent from the creator object to the created object. So here I am asking who is the creator object and who is the created object here in this sequence diagram. Here you are using the create thing. So who is the creator object in this interaction? Creator object. So creator object is this front object because front is the one creating this transaction record. So in this scenario, in this interaction, transaction record is created by the front. So front is the creator object and transaction record is the created object, the one that is created dynamically. Okay. So nothing big there. I mean, if you sometimes get a question in the MCQ with some sample scenario like this, identify what is the creator object and created objects. So you should be able to, now this is one scenario. There could be many other created objects happening in the different examples, in intermediate ones. There, then it will be easy to see from which point it was created. Now you can't say cell phone is the creator object because cell phone didn't create this. Only front is creating this, right? So in this case, he is the creator. This is the created object. Okay. So that is how you do. Then once you have created, after some time, you may not need this. So for that, we use a different label called destroy, something like this. The same creator will destroy it. So after creating this, you destroy. So this is one way of doing that. This is another way. So either you can say X like this, or you can pass a message from the creator object to the created object with the destroy label, right? So an object can destroy itself like this one here, or it can receive an instruction to be destroyed like this. So either way is okay for the reasoning. While we are on the subject of object creation, we should also talk about object destruction. To show an object being destroyed, you place a large bold X at the bottom of its lifeline. The left-hand part of the figure shows an object destroying itself perhaps because a certain amount of time has passed. The right-hand part of the figure shows that an object can instruct another object to destroy itself by passing this label. Okay, so that was about creating and destroy. Moving ahead, framing. How do you use, so this is another concept that comes under sequence diagram. UML 2.0 adds a useful touch to sequence diagrams. You can now frame a sequence diagram by surrounding it with a border and adding a compartment in the upper left corner. A compartment contains information that identifies the diagram. One of the pieces of information is an operator, an expression that describes the type of diagram inside the diagram. inside the frame. For sequence diagram, the operator is SD, where you give the name of the frame. So here, so that all these things we were discussing here were the old UML styles. So the same thing how you do it in UML 2.0, the latest UML version. So along with the operator, the compartment contains the name of the interaction the diagram depicts. Okay. So something like this. You put all your scenarios as we discussed earlier, the UML 1.0 version. Now you put this in a frame, this outer border with this kind of a notation, and you generally put the buy soda or use case. The name of the use case is buy soda. No? So you put that thing with this SD label, right? Or SD operator, basically we call this as an operator. So this is simply known as framing. Now there are different type of frames we'll be discussing here, which is coming under this topic called interaction occurrences. So the framing concept is helpful because you can apply it in a number of ways. Here's an example. If you're creating instance sequence diagrams for the different scenarios in a use case, you'll notice a fair amount of duplication from diagram to diagram. So framing gives you a quick and easy way to reuse part of one sequence diagram in another. You draw a frame around part of the diagram, label the frame's compartment, and just insert the frame with a label, but without the messages and lifelines into the new diagram. This particular framed part is called interaction occurrence. Its operator is REF. So what they are telling is, now you might notice this accept cache, get custom input, this scenario, this whole thing. Now this is one way, the old way of doing things. But if you are using UML 2.0, now for different scenarios, you can't keep on repeating, drawing this again and again. Instead of that, you can put this whole thing into one frame and use that frame instead of using these arrow marks. You can use that frame in this place, right? So that's what they're explaining here. So figure 9.18 shows the frame around part of the best case scenario. The frame part is the interaction occurrence that handles the delivery of the soda. And figure 9.19 shows how to reuse that interaction occurrence in the incorrect change scenario. Right. So let's see how they have drawn frame. Okay. So here you can see this one. This part is now framed in the best case scenario. So best case goes like this: releasing the soda, receiving the soda. So now this part is framed. Now in the incorrect, what is figure 1.9 is mentioning? Incorrect change scenario, right? In incorrect change scenario, you can see instead of drawing these two arrow marks, you use the reference like this: deliver soda. Right? Deliver soda selection. But again, I think this will not work here, because if it is incorrect change, anyway, it will just return a message that incorrect change is there. But I hope you understand the point, how you don't have to draw the same arrow marks here. Now, same thing you can do for this one as well. So here we use the reference. So then when somebody has this diagram, right? So when they are drawing the second diagram, they can just put the reference. To look into what is deliver soda, they can just refer to the previous diagram and then get an idea, right? So that is what is mentioned by that thing, reusing, using an interaction occurrence. Okay. Then you have combined interaction fragments. An interaction occurrence is a special case of an interaction fragment, which is UML 2.0's generic name for a piece of a sequence diagram. You can combine these interaction fragments in various ways. The operator indicates the type of combination. To show a combination, frame the entire set of fragments and use a dotted line as a border between the adjoining interaction fragments. The two types of combination I think will be the most widely used are denoted by the ALT operator and by the PAR operator, right? So I think alter is alternative path and the PAR is the parallel, I believe. So in the ALT combination, each fragment is an alternative, just like the guard condition, and can proceed only under certain conditions. So guard conditions indicate which fragment can take place. So you already learned the fragment concept. Now to mention which fragment is going to function in a particular scenario, we use the ALT operator. In contrast with the ref operator, the idea here is clarity rather than reuse. If you compare figure 9.2.0 with figure 9.17, you will see that guard conditions in the fragments eliminate the need for some of the guard conditions on the messages. This will make things very easy. So here, if you look at this place, when you are using ALT, you can separate the two different scenarios by two different guard conditions. See, sold out or the else part if it is not sold out. So in this case, sometimes these messages which we had used earlier, I mean not messages, the conditions, like we had the earlier guard condition here, no, here no changes here. Earlier we used sold out. We used sold out here. Here also we used something else here. Now those guard conditions are not needed when you use this ALT fragment. Right. So this is called combined fragment. So in ALT type of combined interaction fragments, each fragment is an alternative and proceeds only under certain conditions. So if it is sold out, after all these things happen, if it is sold out, only this happens. Otherwise, this happens. Right? So to indicate that, we use this ALT. So when you are using a combined fragment, you don't have to use some of the guard conditions which we mentioned in the messages. In the PAR combination, the combined fragments work in parallel. So you remember state diagram also we learned, I believe, that how we show the parallel. So if you have parallel tasks that need to happen, if you want to show that in the sequence, you can use the PAR combination. For example, suppose your soda machine works extremely efficiently. It returns the customer's change and delivers the selection at the same time. So this necessitates that several events happen together. So something like this. So earlier, if this was not there, if this PAR indicator is not there, it will give you an idea, okay, after receiving the change only, soda is received. Now, here you want to show that both things need to happen at the same time. So then you put this PAR fragment, right? So this will say, okay, after sold out or whatever this, if this condition is true, check availability is true, then you come and do these two parts, right? After this check availability selection is done, these two will happen together, not after finishing this and then following this. So this will happen together. So that's the idea there. Okay. So I hope that part is clear. Any questions on PAR and ALT? You understood? So tell me if you have understood. When you are using the ALT, alternative combined fragment, what is the thing you can, what is the change you can do in the diagram? When you are using ALT, there's only one point I mentioned there. When you are using ALT, what is the change you do in the sequence diagram messages? Okay. Okay, before I explain, did you first understand ALT and what is PAR used for?
Alternate flow.
Yeah, alternate flow. And what is the other one? Parallel.
Parallel.
Yes, parallel. Yes. So I was asking them since I didn't understand whether they understood. Okay.
Big.
So
Okay.
yeah.
I just happened to look into it when I was like creating a diagram for a client. I actually had to use that maybe 2 days back.
So you see now the importance, no?
Yeah.
How it gives. Yeah.
Yeah. Okay.
Okay. So let me explain again. So we learned this under the topic combined interactive fragments, interaction fragments, right? So the idea here is nothing other than now earlier diagrams we showed these guard conditions and everything, and it had a generic flow of events. I mean, you from top to bottom, it gave you an idea, and we also learned that when we use a guard condition, uh, if that condition is true only, that interaction happens. Otherwise, you have to read it the different way. So, for example, in this case, accept cash, then front calls the get customer input function, then this calls itself, then this condition is true. And in this case, when we say no change, this is a special condition. When the change is not available, then it will finish the transaction. So this is one case. Otherwise, this is not necessary. If the cache is sufficient and everything is sufficient, you have to read it this way from 1, 2, 3, then go to 4 here. You don't have to worry about this part here. Then what happens is, then you have the other thing we learned. We had the same thing in the previous diagram. You had this sold out guard condition mentioned in the message itself. And then the transaction was over with this. But here, that was one thing. Then again, if this is not valid, then you read it like this and go to update, and then you end with this one. When we use this ALT fragment or this frame, what we are trying to avoid, what is avoided here is you don't mention the guard condition in the message itself. You can remove that part. That's the main difference when you use this alternative flow. Instead, you use that guard condition in the frame itself. So you can see you have separated this with a dashed borderline. So this top part works when the sold out is true. Otherwise, this one will work. So all interactions that happen within the sold out guard condition are these two. Else it goes to this. So that is why we use alternative. Alternative means like that if else condition. Same as we learned in the state chart diagram we learned a couple of sessions ago. Right. Similarly, parallel is to show. So if you didn't have this fragment here, the way we would be reading this is okay. Success scenario. Let's say the best case scenario. Accept, get custom input, cash greater than twice is true. Then you go to check availability. Then it will come here. Update cash. Finish this one. Then it will go calling this release soda function and like that. So this release soda interaction and this transaction over, the subsequent one, happens only after this has finished, before you use this parallel. Now, since we have used this parallel fragment, we say that this one and this one happens together. These two happens together. That means soon after this check availability interaction, these two interactions or these two sequence of activities happen together. That is indicated by PAR. Okay. Do you understand? So now coming back to my question earlier, the simplest question I asked was, what is the difference by using or ALT? What do we do special here? or what is the change that is special unlike the other one? What is the speciality? What is the specialty here? What is different? So, Ms. Ansara, what was the difference we do here? What is the different thing we do here? We simply remove the guard condition from the message. So in case you get a question, most probably this might be a question in the MCQ. It can't come in the part 2, because part 2 you will be anyway using either one of this approach. So in this case, the difference in using an alternative combined fragment is that you don't use the guard condition in the message. You don't use it there, but instead you use it in the fragment itself. Okay. That's the important point to keep note of. So I hope you understood that, and let me move forward. So that was the. So before UML 2.0 was introduced, power operator. Introduce the power operator, it was difficult to show the parallel activities, as I mentioned here. If you didn't have this concept, it's difficult to show the parallel activities. Simply that was the purpose. Yeah, here this was what we learned under state diagram. You remember under state diagram we drew something like this dash thing. So here was this set of states work in parallel with this set of interactions here. We learned this rounded rectangles are states. That's how you indicate states. So this was one thing, and then to show that at the same time these two also happen in that GUI interaction scenario, right? So this dashed line here was indicating that parallelism. At the same time, you remember we had somewhere in this case, you can see guard condition. Here also it's concurrent. So here they are using the different word concurrency. Concurrency and parallel are both same words. Maybe in state diagram they're using the word concurrent substates. In our sequence diagram we are using the word PAR, P-A-R, parallel. So again to indicate condition which should happen at the beginning, so we can indicate the condition here at this point where I'm pointing. I don't think we have an example for that. Let me see that here. No. So guard condition concept is here. Yeah, I remember somewhere we used that. Okay. Anyway, here you can see this guard condition used if some timeout is happening, what should happen, right? So that same idea I'm trying to explain here. In sequence diagram also we have that same situation. So guard condition is a way to say if this condition is true only, if we say here, let's say we learned that take here this car interaction scenario. If you look at this, car owner is calling the method of the car key object get button press by passing a parameter selection of a button. Button is passed as a parameter, then in turn this calls the car, and here you can see if the button is equal to lock. So whatever you put in the square bracket is the guard condition. So if this case is true, if B is equal to lock only, this particular interaction is taking place. And then you can see it is sending a message back as blink lights only if B is equal to lock. Otherwise, this will not take place. This particular will place not. Similarly, the beep message as well at the bottom. If B is equal to lock only, this take place. So that was what we indicated by guard condition. Right? So that guard condition only in the ALT, what do we call, interaction diagram or interaction fragment, we noted here. So before using that ALT, generally putting all together, you can see here, I already explained. If cash is created and price only, this check for change will happen. Otherwise, you can ignore this and it goes to the next one, check availability. Right. Then if this check availability is done and then if it is sold out, you have to send this message only if it is sold out. See, the guard condition is mentioned here. So like that, how we introduce this guard condition, instead of using it in the message, like we show here, we show here, we show here. No, not this case. I mean, in this case, no change, sold out scenarios. Instead of doing that in the message, we put that into the frame. Now we are introducing this frame, and then we put that, we remove that sold out guard condition from the message. Here in the display prompt sold out, we didn't mention that label there. We just put it into the frame level, at the frame level. So if it is sold out, these two things will happen: display prompt, and it is over. Transaction is completed with the return cash method being called. Otherwise, it goes to the other one, right? That is what is called else sold out. So that was indicated there. So anyway, if you have a question, you can ask, you can drop a message. I will go ahead. So things what we learned so far. So we learned that our sequence diagrams are behavioral diagrams. So this is updating our knowledge on what we learned. So we learned this concept of objects and the activator, synchronous, asynchronous message, and how they relate with each other. So again, the same, most of the things to refresh here what we learned. We haven't learned grouping. These things will come later. We have learned how a class diagram is used, indicator for an interface, actor, things like that. Okay. Yeah, so that wraps up our discussion on sequence diagram. Now, if you go to your slides, they have given some more summary. So collaboration diagrams I will discuss in the next class. It's just similar to sequence diagram, except you add the sequence number to the interaction. Now in sequence diagram, you show everything at the top, the known objects at the top, and you just pass the messages. So as you read the messages from top to bottom, you know the flow. But in a communication diagram, we show the order through the numbers. Like you give a first this one, second this one, something like that. So collaboration diagram I will discuss in the next class. So here is what we learned. Some of the messages are given here as a summary. What is synchronous, asynchronous? So synchronous means you are expecting a return from the receiver object. Asynchronous means you just one way. You keep on sending the message on. You don't expect a return. In case you want to show a return message, you can use this dashed arrow. And creating object, destroying object, you use these things we learned with the transaction record example. These are some advanced ones, I think, just for memorizing purpose, you can just remember this. You can see some more examples of what we learned. Interaction. Here are some other ones as well. Optional OPT, loop, if you want to show something repeating. So same idea simply, right? So here they are giving some explanations to some of the operators you can use in frame sequences. So OPT is there is a single operand that executes if the condition is true. That means this may be a case where you want to say only one route. Now, if else is the alternative thing is when you have more than one option, like if this is true, this should happen. If it is false, this should happen. That is what you call ALT. But if you have only one condition, only if something is true or if something is false, you want to make that happen, you can't use ALT, you have to use OPT. That is a special case, basically. Right? If that is not true, then you just go with the normal flow. That is what OPT is meaning. Loop is to show, like for loop, while loop, something to happen again and again. You want to show that, you can use that thing. Break, ref, break is again the same concepts you have learned in your programming. So at the design level, how do you show that in your sequence diagram? Like that, additional things are there. So I leave that for your reference. Not necessarily you have to use all of this in your scenario. Some of the things might not be used in the problem statements you are doing. Ignore, consider, assert. You go through them. If you have any questions, we'll discuss. Alternative and else, as we discussed in the case. So if you have now in the example I showed you on the book, there's only one condition and one else statement. So if you have multiple conditions, so this is how you separate them. See, if condition 1 is met, these things happen. If condition 2 is met, these things happen. Message 3 will happen. Otherwise, if these two are false, else part will execute. So simply explain in this diagram. So in a whole thing, they are mentioning what is interaction operator, constraint, combined fragment. So again, so this is the condition. So if x greater than 0, these things will happen. So you can see this object 2 is created. We learned that create label, no? So that label is not mentioned here. So you can see dynamically it is created. So after its creation and its use, you have to finish it off. So you have to destroy it. So that destroys. So this is called self-destruction. Otherwise, we learned alternative way how an object can be destroyed. A create object, such as this guy needs to send the message to destroy it. Here that is not mentioned. So that is shown here. So if x greater than 0 is false, this part will take place. And you don't have object 2 created. That is shown there. So like that loop is shown as I mentioned. You give a condition. So this is how you show a loop sequence, interaction fragment. So if some condition is true, you keep on doing this set of activities and then continue. See, here is a nice real world example when it comes to payment options. Now in use case diagram, you might have this payment option as cash or credit card. So in sequence diagram, to show if you use cash, what you need to do. If you use credit card, what you need to do. So cash will handle this part. Credit card activities will handle this part. Right? It's simple to understand. Like that, you can go through this. So break is similar to what you do it in a programming language. Break is a case where you want to exit the loop, right? So let's say your condition is looped 10 times, you do this add functionality. But when you have a particular scenario where you come to a particular point where your parameter is greater than 0 or something, you want to exit the loop. So in that case, what is the activity you need to take place in the break condition. So that's it. So if you go through this slide and go through this sequence chapter again from the last class, is hour 9. Read this complete chapter as well as the summary part and go through your slides as well, except the collaboration diagram part. And see if you understand and see if you are able to answer past paper questions on that. And then we'll continue from there. Okay, so thank you for your time. Any questions, you can drop a message.